So let's take a simple expression. F is equal to 9/5c plus 32, and we want to solve for c. Now, this is the formula that is used to convert temperature from degree Fahrenheit to degree Celsius. So if we want to solve for c, the first step is to subtract by 32 on both sides, or move that 32 to the other side. And positive 32 would become negative 32. Multiply by 5/9 on both sides. Five over 9 and 9/5 will get cancelled. So the expression for c is 5/9 times f minus 32. So we know that 32 degree Fahrenheit corresponds to 0 degrees Celsius. So if you plug in F is equal to 32, you would find C, which is temperature in degrees Celsius, would be equal to 0. So here we have to solve for H, and V is equal to 1/3 pi r squared H. This is simply the volume of a cone. To solve for X, first step, I multiplied both sides by 3. So 3V would be equal to pi r squared H. The next step, I'm going to divide by pi r squared on both sides. So I will get 3V divided by pi r squared equals H. So we want to solve for I. So first I'm going to multiply both sides by L. So the L's would get cancelled. So L times Q would be equal to A minus I. If I move A to the other side, I'd have LQ minus A equals minus I. But we want to solve for I, so I'm going to multiply both sides by -1. So negative LQ, negative times negative A is positive A, would equal to -1 times negative I, positive I, which would imply I is equal to A minus LQ. So we want to solve for X. Of course, we can find the common denominator and solve, but there are other ways to solve this also. Since I'm solving for X, I don't want to do the common denominator business. So what I'm going to do is first subtract 1 on both sides. So I get P minus 1 equals negative C over S. Multiply by -1 on both sides. The right-hand side would become C over S. The left-hand side, if I distribute, I'll get minus P plus 1. Minus P plus 1 is simply 1 minus P. That would equal to C over S. So if I cross multiply, or flip and multiply, I would get S times 1 minus P equals C. I divide by C, 1 minus P. I'll get the answer. Of course, I did that initial step of multiplying by negative so that I don't get any negatives in the final answer. But if you don't do it, you'd end up getting a negative C divided by P minus 1 as the answer. So this is an equation that comes commonly, or definitely will, in electronics. Resistors connected in parallel will have this particular equation in finding total resistance. So we want to solve for R first. So I'm going to keep the 1 over R as is. There is nothing in common between those two expressions. So I'm going to multiply and divide by R2. And take the second expression, multiply and divide by R1. The reason being the least common denominator is R1, R2. So we have R2 over R1, R2 plus R1 over R1, R2 equals 1 over R. The common denominator is R1, R2. So I can combine the numerators, R2 plus R1. If I flip on both sides, I could solve for R. So R would simply be equal to R1, R2 divided by R1 plus R2. So we want to solve for R1. So the process is the same as the previous problem. So I'm going to move 1 over R2 to the left-hand side. So it becomes negative 1 over R2. There is nothing in common between those two terms. So the least common denominator is R2 times R. So I'm going to multiply the first expression by R2, the second expression by R. So R2, R, numerator R2, minus R divided by R2 times R. Now I have a common denominator, so I can combine the numerators. So R2 times R, numerator R2 minus R equals 1 over R1. If I flip on both sides, R1 would be equal to R2R divided by R2 minus R. Okay, we have H is equal to K times A multiplied by T1 minus T2 divided by L. And we want to solve for T2. So since T2 is inside the product there, want to isolate T2 first. So I'm going to multiply by L on both sides. So L times H would be equal to K times A, T1 minus T2, because the L's on the right-hand side will get cancelled because we are multiplying by L on both sides. The next step, I'm going to divide by Ka on both sides. that would simply leave me with T1 minus T2. I want T2, so I'm going to move T1 to the other side. So LH over Ka minus T1 would be equal to minus T2. We've solved for minus T2, but I want plus T2. So I multiply both sides by -1. Oops. So I'll end up getting minus LH over Ka. -1 times minus T1 is plus T1. And -1 times minus T2 is T2. Therefore, the expression for T2 is T1 minus L times H over K times A. So in this expression, we want to solve for F2. So very first step, I'm going to multiply both sides by this denominator because it has an F2 in it. So F times F1 plus F2 would be equal to F1, F2. Distribute the F times F1 plus F times F2 is equal to F1 times F2. Since we are solving for F2, I'm going to move the second term on the left-hand side to the right. So F times F2 would become negative F times F2. On the right-hand side, I have an F2 in common. So F times F1 would equal to F1 minus F. I'm pulling out the F2 that is in common. If I divide by that term on both sides, I will end up getting F2 by itself. So F times F1 divided by F1 minus F would be equal to F2.